Good evening, guys. In continuation of the discussion, friction. Okay, so this is the second class of the friction chapter, and friction comes under that laws of motion only. Okay, so let us discuss. Okay, I am Mr. Amarnath. So basically, we already discussed what is the that one limiting friction. Okay, it means maximum friction. That part is already discussed. Okay, maximum frictional force is nothing but uh, that is F max. Well, this is also called limiting friction. Okay, limiting friction. We'll do some questions on that limiting friction. Or this is called F max. Okay, that is what we get. That is, it is mu into n. Okay, so this is the maximum force that can be given by two surfaces in contact. Okay, so let us discuss this part first. Okay, graph of friction. I have already told you, say this is a surface and here is some object, okay? I have applied some force and obviously if the surface is frictional, okay, there will be certain mu and there will be certain F max, okay? And the F max will be what? Mu into M, okay? This will be a value only. Say this value is say 10 Newton. It means if I apply more than 10 Newton, so then only the object will move. Or if I apply less than 10 Newton, then the object will not move, okay? If I take the example of F max as 10, okay? Just for example only, nothing else. Otherwise, we need to calculate the value, na, F max. But if I apply less than that F max, okay? So whatever force I apply, the frictional force also, it is a self-adjusting force, we have already told you, na? So it means frictional force also will be that only, okay? So if I draw the graph, okay? If I draw the graph, say this is the applied force and this is the frictional force, okay? So if we increase the applied force, say increased force is applied force is 1, so frictional force also will be 1 like this only, okay? But applied force is 2, frictional force also 2, okay? Like this applied force is 10, so frictional force also will be 10. But if the applied force is 11, the frictional force will be 10 only, na? If I take the example of 10 only, okay? So it means the graph will be to some extent like this, okay? After that, it will be constant, okay? That part is called F max, okay? This part is called F max. So actually what happens, you see, N is normal reaction here, okay? N is normal reaction here. And mu is what? Mu is a quantity that denotes the roughness of the surface, okay? That mu is called coefficient of friction. What is mu? That is called coefficient of friction. Coefficient of friction means coefficient of friction means it is surface, okay? It indicates the more will be the roughness of the surface.
Okay, sir.
If you keep on applying the force, okay, frictional force will go on increasing, but after certain time, then frictional force will be limited one, okay? Your applied force will be infinite, na? You can do anything, but frictional force will be always, it has some maximum value. That maximum value is called limiting friction, okay? If you somebody asks you what is limiting friction, the maximum possible value of frictional force is called limiting friction, okay? Maximum possible value of frictional force. Maximum possible value of frictional force. Sorry, see, this is an ideal graph only, okay, whatever I'm drawing. Here actually F max is nothing but mu into n, okay? And here mu is called coefficient of friction. But in reality, that graph is little bit different, okay? In reality, the graph will be little bit different. So actual practice. So you just tell me one thing. Try to answer this question first. Say one car is stationary and just waiting on the highway, okay? Let's say it is a damaged car, okay? So what we do, everybody comes to push it, okay? So it is very difficult. Pushing a stationary car to move is difficult, or uh, just a moving car, we are going to push it so that it keeps on moving. So that is difficult. So which one is difficult? To make a stationary car moving or a moving car keeps moving? So which one is difficult task for us? What do you think?
The stationary car that we have to move.
Yes,
That is difficult.
yes, that is very good. Because stationary car has inertia stationary. We have to apply large amount of force so that it keeps on moving. But once it starts moving, that interlocking breaks. I have already told you the interlocking between two surfaces. So that keeps on it moving only. So we have to apply a little force only. So then also it will keep on going. Okay. So that is why the graph is actually a little bit different. Okay. The graph is actually first increases, then here is a small kink, small. I am showing it this is large, but for explanation only. Okay, then it becomes like this. Okay, this is the actual graph actually. So it means that is the maximum only the car will start moving. That is, but after once it is keep on moving now, if you apply this much force also, little less force also, then also it will keep on moving. Okay, so it means this is called maximum static friction, and that is called kinetic friction. Okay, say this is F1 and this is F2. So here F1 is called maximum static friction. Static means stationary. Okay, because till that the particle is not going, the car is not going. Maximum static friction. So here it is F1 equal to mu into n only. Okay, mu into, this is called mu. Symbol is mu. Symbol is not m. That is MEW, like that. Okay. So F1 is mu into n, but here I write mu s for static. Okay. Mu s. It is a large value. Okay. Mu s. But once the car start moving, then the frictional force drops little bit. Okay. Say in my example, I given you the 10 Newton. So what happens? If I apply 1 Newton, the retarding force will be 1 Newton. If I apply 9 Newton, the opposing force will be 9 Newton. If I apply 10 Newton, the opposing force will be 10 Newton. But if I apply 11 Newton, okay, it means the car will move. If the car will move, so then of course the frictional force will be not 10 actually, little less than 10. Okay, it is 9.5 like this. Okay, that is F2. So here F2 is called kinetic friction. Okay, what is kinetic friction? On the surface when the sliding occurs. Okay, that is F2. So F2 is called kinetic friction. F2 is called kinetic friction. But remember, if in the question kinetic friction and static friction are not separately mentioned, so definitely I will take only the static friction only. Okay, that means we can take that both the values are same only. Okay, means it's mu s and mu k both are same. We can assume like that. Okay, so kinetic friction symbol is F. Say you can write Fk also. Fs, Fk. Okay, in place of 1 and 2 you can put Fs or Fk also. So only, okay, symbol that is up to you only. So this is Fs, or you can put Fk. So for you Fk it will be mu k into n. Okay, mu k value is little bit less than mu k is little bit less than mu s. Okay, in general, but if in the question they have not mentioned about mu k and mu s, it means we will assume that the both are same, and then the graph will be like this. Okay, there will be no kink at the top. Okay, simply like that. Okay, nothing else practically. Okay, so let us do some numerical. Okay, here mass of the block is 2 kg, surface friction is 1 upon 4, applied force is 10 Newton only. Okay, now you see, if I draw the Liebel diagram, so this is the object. Okay, so that gravitational force is 20 only, normal will be n, applied force is F equal to 10, but I don't know what is the friction. Okay, because say friction is self-adjusting, so I don't know exactly the friction value, but I know that n equal to 20 now. But I know that F max can be mu times n. Mu is 1 upon 4 and it is 20. So it is 5 Newton. It means maximum opposition that can be offered is 5 Newton. But you have applied 10 Newton, remember. You are applying more than 5 Newton. It means friction will fail. Na? So that frictional force will be now what? Therefore, frictional force will be, now it cannot go beyond 5. Okay, that is 5 only. So now the frictional force is what? Only 5. Because it cannot go beyond 5 Newton. Na? That is why. Okay. Have you understood?
Yes, sir.
Yes, sir.
Okay. If you see, if you apply instead of 10, if you apply 11 also, na, then also answer is 5 only. Okay. If you apply 12 also, then also answer is 5 only. Okay. So one more thing I want to just teach you. So this is 10 Newton. Okay. In my question, actually in this question, it is 10 Newton. Okay. Uh, so if we talk about if we draw the free body diagram, here you see, here it is 10 Newton and here it is 5 Newton. Okay. So in the that horizontal direction, what is the net force? Net force is 10, net force is 5, or net force is 10 minus 5, or net force is 15. What do you think? Net force, F net along the horizontal, along this direction. So right directional force is plus 10, left directional force is 5. So this is called actually F net, okay, net force. And you know that net force is always mass into acceleration. Okay, so here mass is 2. So it means here you can check 10 minus 5 is 5. It is 2. So it means from that I can calculate acceleration equal to 5 by 2 also. Okay. It means the object will start moving with this acceleration in this situation. But if I apply a force only 2 Newton, if I apply a force 2 Newton, here the friction will be that can go up to 5 Newton. Na? So friction will be 2 Newton only. So it means the object will not move because right directional force is 2, left directional force is also 2. So 2 minus 2 will be net force equal to 0 only. So if the object has 0 force, so how can it accelerate? Okay. So that is actually not asked in this question. In future, we will be discussing such questions also. Okay. But in this question, what is the answer? Answer is that 5 only. Okay. Because my applied force is more than F max. So obviously frictional force will be F max only. Please try this question. Here actually the block given as given here is having mass 8 kg. And surface frictional coefficient is 1 upon 2, and applied force is F, which is equal to 60 Newton. So we want to calculate what is the frictional force between the two surfaces in contact. Okay. At this moment, same procedure. First, you have to calculate maximum frictional force, what it can be, means F max. It means limiting friction. Okay. And then you have to check whether your applied force is more than limiting friction or not. Okay. And accordingly, you have to take the decision how much friction will take place. Okay. So you please try this. So this is the solution. Let me draw the Fibonacci diagram. As I have already told, 8 kg, it means downward force will be 80 Newton. Upward force will be N. Rightward force will be 60. And leftward force, I don't know what it will be, okay? Because it is a variable force. It varies from 0 to F max, okay? So now let's first calculate F max. The F max is mu into N, okay? So mu is half, half. And N will be 80 only, okay? So it will be 40. Yeah. It will be 40. Now you see the applied force is more than 40. It means the object will just start dragging over the surface. And frictional force, obviously, it will be the maximum frictional force only, okay? So therefore, frictional force, small f is the symbol of frictional force, okay? So therefore, small f is nothing but F max, and which is equal to 40 Newton. You are absolutely correct, okay? Because applied force is greater than the limiting friction, okay? Therefore, frictional force will be F max only. So this is the answer, okay? 40 Newton is the answer. Well, so let me try another question, okay? Here, given that mass of the body is 20 kg, applied force is, that is a time varying force, okay? 2t, it means force will keep on increasing. So if time is 40 seconds, at that moment, what will be the acceleration of the block? Okay. What will be the acceleration of the block? See, that is 20 kg. So it means this is 200 Newton. This will be the normal force. And this will be the applied force. Applied force equal to what? 2 into T. But they are asking at 80. No? So it means it will be 2 into 80 is 160 Newton. Okay. And here it will be frictional force. I don't know what is the value of frictional force because it is self-adjusting. So first calculate F max. So F max is equal to what? Mu into N. Mu is 1 upon 2 and N is 200 only. So it means it is 100 Newton. Okay. So you see friction is 100 Newton because applied force is more than friction. Na? So now you see on horizontal direction, rightward force is 160, which is more than the 100. Okay. So obviously the object will slide. Okay. It means it starts accelerating. So we know that from Newton's second law, we already understood that sum of all the forces equal to mass into acceleration. So rightward force I have taken as positive 160. Leftward force I have taken as negative because it is a vector quantity forces. And mass is given as 20 and which is A, I don't know. So 160 minus 100, it is equal to what? It is equal to 60 equal to 20A. So from that we can easily say that A equal to 3 and SI unit of acceleration is 3 meter per second square. Okay. So with that speed, with that acceleration, it will start sliding. Okay. And once you study the kinematics, na, V equal to U plus AT, S equal to UT plus half AT square, okay? Then you can calculate the displacement, you can calculate the final velocity after certain time, and lot of problems can be solved, okay, using these data. But now, for the time being, we have calculated only acceleration, okay? How? First, we have drawn the Fibonacci diagram. I have checked how much frictional force will be applied, okay? How can I check it? Just calculating F max. I calculated F max, I found it is 100. And I know that applied force at that moment, 80 second, applied force is 160. Because 2 into T, T for time. So 2 into 80 means 160. So which is greater than F max. So it means the object will slide. So as it slides, so obviously acceleration will be there. So from which concepts, say along this axis, I have applied the force equation. Okay, sum of all the forces equal to mass into acceleration. Who told? Newton's second law. So rightward force is positive, leftward is 100, negative is equal to mass into acceleration. Acceleration is this. Okay. Say if it is not 80, if it is 40, so what should be the answer? Can you say? Can you suggest? Do you have any idea? If T is say 40, okay, then applied force will be what? Applied force will be 2 into 40 only, no? So it means applied force will be 80 at that moment, okay? When time is 40 seconds, at that moment applied force will be 80, okay? But this is 80. But frictional force can be up to 100. Frictional force can be up to no. It cannot be minus. Acceleration never be negative, okay? Why I'll say. You see, the frictional force can be up to 100, but you know that frictional force is self-adjusting only, na? So as you have applied 80, so frictional force automatically will be 80 only, because 80 is less than 100, na? You see, have you seen ever you are dragging an object rightward and object starts going leftward? Have you seen somewhere? Just because
Sir.
of friction, object is going backward. Have you seen somewhere? It is not like that, na? Say you are dragging your table. Either the table will not come or it will come. But you are pulling rightward and table is sliding backward. Is it possible? Then only that -1 meter per second square will come, na? So that is why, okay? Answer will not be negative, never be negative actually, okay? In these cases. So acceleration will be 0 only, because you see now the rightward force is 80, leftward force is also 80. So 80 minus 80, net force will be what? 0. So it means net acceleration also will be 0. Okay. But the time is now bigger. So applied force also will be bigger. Okay. It means it will be more than 100. It will be more than 100. And hence the object start accelerating. Okay. Can you answer at t equal to, so acceleration will be 0, huh, in this, if t is 40. So can you answer at t equal to 30? What will be the answer? Directly looking at the solution on the board,
Sir,
you
is
can
zero.
answer. At t equal to 30, what is the acceleration?
Zero.
Can you answer at t equal to 30, what will be the acceleration? Check at 30, what will be the net force, what will be the applied force? Check it.
Third, the acceleration will be 0.
0. At t equal to 30 also acceleration will be 0. Very good. Because at 30, the force will be 60. Okay. It means you are pulling with 60, but friction can be up to 100. So friction automatically will adjust to 60, na? Because frictional force is always variable from 0 to F max. F max is 100. Means friction can self adjust from 0 to 100. So 60 easily can be handled. Na? That is that. Very good. Please try the next one. Please try this question. Let me try. First, let me draw the free body diagram. As it is 10 kg, so downward force will be 100 Newton weight, and normal reaction will be upward. Okay. And the applied force is equal to, you see, T is 4, no? So it means applied force equal to 5 into 4 plus 5. So 5 4s are 20, 25. Applied force is 25. Okay. Okay, okay. Now I don't know the frictional force, okay? So let me check it first, F max. Let me check first, calculate F max. F max will be mu into N. So mu is 1 by 5 and N is 100. So it is 20. Okay. So you see, applied force is more than frictional maximum capability. So obviously the object will move. Okay. So here frictional force will be 20 only. So now if we write the force equation, right direction force is 25, left direction force is 20. So I know that sum of all the forces on the on x-axis equal to mass into acceleration, we can say. So rightward force is positive, leftward force is negative, mass is 10 kg and acceleration. So it is 25 minus 20, it is 5. So 5 equal to 10A. So A equal to half. Absolutely correct. Absolutely correct. Very nice. Very nice. Okay. 1.5. 1 point. Oh, sorry, 0.5. Half means 0.5, 0.5, 0.5. Okay. Because time is 4 seconds. Na? 5 into 4 plus 5. Value of t is 5, nothing else. So, have you understood? Can I move to another question?
Yes, sir.
Okay. Please try this. Sorry. Please try this. We have 5 kg block. Applied force is similar like 5t plus 5, okay? And frictional coefficient is 1 upon 5. You need to find out the time when the block starts moving, okay? When the block starts moving. Remember, when the applied force is equal to F max, at that moment object starts sliding, starts moving. Starts, okay, starts. Okay, let me see. In this question, it is given that mass is 5 kg, frictional coefficient is 1 upon 5, applied force is 5t plus 5, okay, some variables. We need to find out the time. I find the time when the object starts moving. So, when the applied force will be equal to the F max, no? So this is the object. So this is applied force. And if it equals to F max, then the object starts moving. So F max value is what? It is mu into N. And mu is 1 upon 5. N is 50. So it means it is what? It is that one. 10. Okay. Maximum opposition is possible up to 10 only. Okay. So when F is greater than or equal to F max, then object slides, okay? Object slides. So F is here 5t plus 5, okay? So it should be greater than equal to say F max. F max is 10 only. So we can say that 5t greater than equal to 10 minus 5, okay? 10 minus 5. So it means 5t greater than equal to 5. So it means t greater than equal to 1, okay? It means when the time is 1 second or more than it, the object will be moving. So it means it starts when it starts at t equal to 1, okay? Therefore, it starts moving at t equal to 1, okay? This is the answer. Nice, nice. Okay, can I give you one more question of this type?
Yes, sir.
I think I have done this problem earlier also, but you please try once more, okay? Find the value of t when the object starts moving. Okay. Here also, mass is 20 kg, applied force is 5t square plus 5. Coefficient of friction is 1 upon 4. Find the value of t when the object starts moving. If f equal to 5t square plus 5 under root, okay? This is like this, okay? So, yeah. I think correct, okay? You are correct. So far, I remember. Okay. Let us see. Again, the object will move only when f equal to or greater than f max, okay? So here f max is what? Mu into n. Mu is 1 upon 4 and n is 200. It means 50. So applied force must be greater than equal to 50. Okay, you can write equal also because we want starting time only, na? Excellent, excellent. Both are correct. Both are correct. So it is 50. So 5t square plus 5 equal to 50. 5t square equal to 45. So t square is 9. So t equal to plus minus 3. But I have to write plus only because minus 3 has no meaning. Na? Negative time has no meaning. So at t equal to 3 seconds, the particle start moving and after that it will keep on moving only. Okay. I'll help you doing this. First you read this question. First you read this question. Say this is an object and I have applied a force. Okay. But remember, I have applied a force. Force is not constant. Force is varying with time. Okay. Force is varying with time. Here you see F is given as 5t square plus 5. T means time. say at t equal to 0, say I started seeing the clock now, okay, t equal to 0. So at t equal to 0, force will be what? Force will be 5 into 0, 0 plus 5, okay? And at t equal to 1, if at t equal to 0, f is 5. At t equal to 1, so it will be what? 1 is square. 1 is square into 5 is 5, 5 plus 5, 10, okay? Force is 10. So it means as time always increases, na? Time never decreases. Time never goes back also, na? Time always increases. So it means in this situation, our applied force is also increasing, okay? At t equal to, you can say at t equal to 2, you can find t square means 2 square. 2 square is 4. 4 into 5, 20, 25. It will be 25, okay? So it means you see force is going on increasing, okay? It means, say there is a big refrigerator, okay, on your in your that one kitchen, okay, and you are applying a force and जोर लगा रहे हो, ठीक है, जोर बढ़ा रहे हो, यही बात, okay? So question is, at what time the object will move, okay? That is the question. If you start applying the force according to this expression, at what time, first second, second second, third second, fourth second, at what time the object will move? That is the question, okay? So how can we solve? You see technique, see the technique, very easy, very easy. First of all, draw the free body diagram. So downward it will be 200, upward it will be n, rightward applied force, leftward frictional force. I don't know what will be the frictional max force, okay? So for that I have to calculate first the maximum value. So maximum value will be what? It will be mu into n only, and mu is what? 1 by 4, n is what? 200. So it will be what? It will be equal to that 1 by 4 into 200 means 50. Okay, 50 Newton. Well, it will be 50 Newton only. F max. It means what? If you increase your force, the object will start moving only when the frictional force will be 50 Newton. Okay. So it means F equal to applied force F equal to F max. Then only the object will move. So F equal to F means what? F means in the question it is given. In the question it is given F equal to what? 5 t square plus 5. But what is F max? F max is already calculated to be 50. Okay. So it means 5 t square equal to that will be 45. Okay. 50 minus 5 will be 45 only. So it means t square will be 9. 45 by 5 is 9. So it means t equal to 3. Okay. You cannot take minus 3, huh? Because minus time is does not have any meaning, na sense. So you have to take plus 3 only. So at 3 second, if you start, say your father is started pulling the freeze according to the formula, and you are watching the clock, okay? It means that t equal to 3, okay, is the answer. You please copy it, okay? First you copy it, then I'll give you another question, okay? So in this question, actually here mass is 5 kg. Applied force is also time varying, okay? That is 5t plus 5, okay? With time, the force is increasing. You can see with the different t, F goes on increasing, okay? Remember, time always increases. Time never decreases. I have already told you. So if you draw the free body diagram, you can find here it is 50 and here it is n, okay? So from that I can say n equal to 50. So F max equal to mu into n. F max is 1 by 5 into 50. It means that is 10 Newton. Okay. Means unless and until this force becomes equal to 10 Newton, the object cannot move. Okay. So what you can write for start moving, so applied force 5t plus 5 must be equal to F max. Okay. So it means 5t equal to 10 minus 5 is 5. So excellent, excellent, excellent. T equal to 1 second. Okay. Great. So it means at t equal to 1 second, the object starts moving. So as it moves, so keep on moving on 3 also, 4 also. Okay. Yes, yes, yes. Sure. Oh, you are correct. You are correct. You are correct.